For this video, what I want to do is show you how to use the tangent, sum, and difference identities to find the exact value. I'm only going to do one of them, but the process would be the same whether you are dealing with the sum or the difference. You just have to pay attention to which one you are dealing with. So there's a couple things that I want to talk about before I start, just to keep in your mind. We are going to use the unit circle to help us find the exact values. Remember that the unit circle is all of the coordinates are in the form cosine, comma, sine. And we also need to remember that tangent is equal to sine divided by cosine. Okay, so we are going to use coordinates on the unit circle to help us find the exact value, as well as we're going to use the expression that tangent equals sine over cosine to fill in our values. Okay, so the sum and the difference identities, the sum tells us that if we have the sum of two angles, the tangent of the sum of two angles, that we can say that tangent of the first angle plus tangent of the second angle is equal to 1 minus tangent of the first times tangent of the second. Okay, the difference formula tells us that the numerator is going to be subtraction and the denominator is going to be addition. That's the only difference between the two formulas, is where the plus and the minus go. So in a sum, the addition is in the numerator and the difference is in the denominator. For a difference, the difference is in the numerator and the addition is in the denominator. All right, so let's get started with the example that I have here. The first thing that you want to do is you want to find two values that have a sum or a difference that equals 195. Okay, so the values that I picked was I picked tangent of 225 degrees minus 30 degrees. So I picked two values that are on here. 225 is right here, and 30 is here. Okay, so we're going to use those coordinates to help us find the tangent. So the first thing that we want to do is we want to rewrite this using the rule. So since it is a difference, I'm going to use this rule, and we want to pay very, very close attention to the signs that we use. So we're going to start by writing tangent of 225, and then the subtraction is going to go in the numerator. Tangent 30, and then we would write this all over 1 plus tangent of 225 times the tangent of 30. So what you want to make sure is that they're always opposite signs on the numerator and the denominator, otherwise they would just cancel out. Okay, so be very careful with that. All right, so now what we want to do is we want to replace tangent 225 and tangent 30 with what they're equal to. So I'm going to start with tangent of 225 degrees. So I would go to 225 degrees on the unit circle, and we see that that's the ordered pair negative square root 2 over 2, comma negative square root 2 over 2. So remember that tangent is sine over cosine, and it's cosine comma sine. So we would take this y coordinate on the top and the x coordinate on the bottom. In this case, they're the same, so I just end up with 1. So in my equation, I'm going to replace the tangent 225s with 1. Okay, the other values, I still would write the 1 plus, and the subtraction I would keep the same. So now let's find the tangent of 30. Okay, so tangent of 30, we would go to the unit circle, and we would find the point for 30, so we would use 1/2 over square root of 3 over 2. This simplifies into 1 over square root of 3, and we do have to rationalize the denominator to get rid of the radical in the denominator. And so when we do that, we end up with square root of 3 over 3. Okay, so all we did was we replaced tangent 225 with an equivalent expression and tangent 30 with an equivalent expression. All right, so now what we have to do is we have to simplify. If we were allowed to leave radicals in the denominator, we could leave it like this, but there's two things going on here that we're not allowed to have. The first one is we have fractions within fractions, and we also have radicals in the denominator. So we do need to simplify this. So the first thing that I'm going to do to simplify this is I'm going to multiply both the numerator and the denominator by 3. And by doing that, I'm essentially multiplying by 1. So I'm going to just distribute this 3 into my equation. So I end up with 3 minus square root of 3 because the denominator cancels out. And then in the denominator, I end up with 3 plus the square root of 3. All right, so now don't think that I can just cancel out the 3's and all of that stuff because they're not the same. Remember that with the numerator and the denominator, if you have addition or subtraction, the only way that they can cancel out is if they're exactly the same. So what we have to do is we have to rationalize the denominator. We have to make it so that we don't have a radical in the denominator. And to do that, what we're going to do is we're going to multiply both the top and the bottom by the conjugate of the denominator. The conjugate of the denominator just means the same numbers, different signs. So I'm going to multiply by 3 minus square root of 3 to both the numerator and the denominator. By doing that, this is a difference of 2 squares. So my middle two terms, the 3 square root of 3 and the negative 3 square root of 3, will cancel each other out. Okay, so the first step is we're going to FOIL the top. If you know the rules, you can do this in your head. I'm just going to show all the work out. 3 times 3 would give me 9 minus 3 square root of 3. And then I would do the same thing with the second number. I would end up with negative 3 square root of 3. And then remember, when I take a radical times itself, it just ends up with what's inside. And because I have a negative times a negative, I would put a plus 3. All right. In the denominator, I'm essentially doing the same thing. I'm going to take the 3 times 3 and I'm going to get 9. Okay, this part right here would give me a negative 3 square root of 3 plus a positive 3 square root of 3 would just cancel out, so I'm not even going to write it because it will always cancel out. And then square root of 3 times square root of 3 gives me 3. So now we just simplify the numerator and the denominator. In the numerator, I can take 9 plus 3 gives me 12. Negative 3 plus negative 3 gives me negative 6 square root of 3. And this whole thing would be over 6. So to simplify this expression, since both of them can be divided by 6, I would end up with 2 minus square root of 3. And this would be the exact value for tangent of 195 degrees. Okay, as always, thanks for watching. If you have any questions, please let me know. If there are additional topics you need me to cover, please let me know that as well.